Okay, so this is day 5 here. We're keeping going with simplifying radicals and doing some operations with radicals. And the only thing we're adding today is, well, what if there's more than one term in our denominator? Okay, so this is just a quick do now. Again, I'll hope to make this video only about 10 to 15 minutes, and you can watch as little or as much as you want to help you with the homework. Hope everybody's doing well. All right, so the do now here, we've got this expression, 3 minus square root of 5 all over square root of 6. And the couple questions, obviously, how many terms in the numerator? There's just 2. How many terms in the denominator? There's just 1. And then simplify, well, we go back to ask the questions we've asked ourselves before. Number 1, are my radicals simplified? Root 5 and root 6 are simplified. So I can't do anything more with those. But the second question I asked myself, is there still a radical in my denominator? The answer to that is yes. So I need to rationalize. I have 3 minus root 5, and hopefully this may just review from what you did on homework number 4. But I need to multiply both numerator and denominator by radical 6. That is the process of rationalizing. We're taking an irrational denominator, multiplying it by itself, and giving it a rational denominator. That is rationalization. Since we multiply the denominator by root 6, we have to multiply the numerator by root 6. Distribute the distributive property, root 6 times 3. I've got an outside number 3 and an inside number. It gives me 3 root 6. I'm getting a little jammed for space, sorry. And then root 6 times root 5 are both inside numbers. So inside times inside, root 30, and root 30 cannot be simplified. So we're left with 3 root 6 minus root 30, wow, over 6. All right? So again, these hopefully a review from yesterday. Today we're just going to practice a few more of these. You're not going to do a daily practice, so we'll skip over these slides. Isn't that exciting? And now we'll go to answer this next question. What if you have 2 terms in your denominator? So far, we've only had 1 term, and we've rationalized. If we have 2 terms, we're going to see if we can combine those 2 terms. That's what we'll do today. And then in the next lesson, we're going to learn something called conjugate the denominator, which is another way to get rid of a radical down there. Okay, so let's look at some of your in-class. So you should be able just to follow along with that in-class practice sheet as we'll do these, 6 problems together, and hopefully that'll give you enough to do the homework. Looking at number 1, again, same questions. Root 5 and root 3 are both simplified. So I'm going to multiply by root 3 over root 3, rationalize just by doing the denominator. My new denominator is this 3 times this root 3 times root 3, which is 3, which gives me 9. And then I need to distribute my numerator. Root 3 times 2 root 5 is going to give me 2 root 15. Plus root 3 times the 4 is 4 root 3. Okay. By root 15, simplified. Root 3, simplified. The 2, 4, and 9 coefficients, I cannot reduce those, so I am finished. Number 2, what I notice is different is I just have a variable in my radical term down here. I also notice that I can simplify root 8. So remember, root 8 is 2 root 2. So if I were to rewrite this, I'd have 3 minus root 3a over 4 times 2 root 2a. Again, I just took the root a part and turned that into 2 root 2a. Okay, so that gives me 3 minus root 3a all over 8 root 2a. So as I look now, my root 3a is simplified. My root 2a is also simplified. But it's hanging out down there in the denominator, and we can't have that. So I rationalize. Root 2a over root 2a. Now, my new denominator is, let me just pull the screen up a little bit, 8 times 2a. In fact, I wrote that poorly. Didn't give myself space. See, I'm making mistakes here too. My new denominator is 8 times 2a. Because the 2a times that root 2a times root 2a is 2a. So my new denominator is down here, 8 times 2a. My new numerator, let's go back up here and distribute. I have 3 root 2a minus root 6a squared. Because my inside 3a times my inside 2a gives me inside 6a squared. So let's simplify a little bit here. I have 3 root 2a minus this 6a. Well, an a can come out, but that 6 has to stay in. All over 16a. This root, so again, let me explain what I did in this last step. The 3 root 2a is still the same, this part right here. Minus, I looked at this 6a squared, and notice that the a squared and a can come out. The 6 stays in, okay? And then my denominator is just the 8 times the 2a gives me 16a. So as I look at each of these terms, well, the root 2a, simplified, root 6, simplified. There's no radical down here. And my coefficient, 3 and 16, and this 1 over here, and 16 cannot be simplified, so I'm finished there. Okay, in the spirit of not making you watch all of these, let's skip down to number 4. And the reason I'm skipping down here is because now I have 2 terms. Well, notice from a couple days ago, I have a root 5 and a root 5. Since my radicals are the same, I can combine them. I add the coefficients. A 2 plus a 4 would be 6 root 5. And my numerator, I can't do anything with that. I can't combine a non-radical term with a radical term. So all I've done is combine like terms down here, and I have a new denominator. Now this looks like something we've seen before. Root 3, simplified. Root 5, simplified. I can't do anything there, but that root 5 in the denominator means I'm going to have to rationalize. Multiplied by root 5, multiplied by root 5, and I get 3 root 5 minus root 15 in my numerator when I distribute, right? The root 5 times the 3 gives me 3 root 5. The root 5 times the root 3 gives me root 15. And in my denominator, I have 6 times 5. Well, that's 30. Root 5 simplified, root 15 simplified. This 3 and 30, I could simplify, but there's the 1 here. I would basically have to split that up into 2. So it would be like 3 root 5 over 30 minus root 15 over 30. And then simplify that to 1/10. But, you know, to me, that's more work than you need to do. So you can leave it as 3 root 5 minus root 15 all over 30. Last one. Oh boy. I'm looking at my denominator. I see a root 3x, a root 3x. I know I can combine those, so I look at my coefficients. 5 minus 2. So I have a new denominator of 3 root 3x. Okay. My numerator, I'm not going to change anything there. 12x cubed, I'm not going to change anything for now. I do notice that x cubed can be simplified. 5x. Okay. So this looks like something we have seen before. Let's simplify that numerator term really quickly, though. I see a 12x cubed. So I know 12 and the x cubed can be simplified. 12 I've done so many times, I know it's 2 root 3. 2 times 2 times 3. And this x cubed is going to be like an x root x. Okay, so that's that. The root 12 is 2 root 3. So let's rewrite that. A 2 comes out, and the x comes out here and here. And what stays in is 3x. Okay? So root 12x cubed is the same as 2x on the outside, 3x on the inside. Okay? Then plus 5x And here's my denominator of 3 root 3x. Again, I underlined those just to show you what came out from my original 12x cubed and what stayed in. Rationalize. Why? Because this radical is simplified, this radical is simplified, and otherwise I'd be done, but I can't have a radical in my denominator. So multiply numerator and denominator by root 3x, and I'm left with this. Let's do the denominator first. 3 times 3x is going to give me 9x. Okay? 3 times root 3x times root 3x is 3 times 3x, which is 9x. In my numerator, root 3x distributed here, well, the root 3x times the root 3x is 3x, times 2x gives me 6x squared. So again, I'll do it off to the side. I'm taking 2x times root 3x times root 3x. Well, this is just 3x. So 2x times 3x gives me that, 6x squared. Then I go back here and distribute it to this. Well, now I've got an inside and an outside. So plus 5x root 3x. And that is my final answer. And I know that because this radical is simplified. And if I look at my coefficients, 6, 5, and 9, they don't share a common factor. Now, as I look at this, I also notice that my coefficient has an x squared here, an x here, and an x here, so I can simplify the variable. So I would get 6x plus 5 root 3x all over 9. Again, this x can cancel out with this x squared and leave an x in my numerator. This x down here, see this here, and the x in that cancel out, and so we're left with this. Okay. Any questions, please send me an email. Good luck with the homework.